since the facial expression often offers very rich information, not only about the content of what's been happening in the story, but also about how the artwork was created. This can be very useful for comparative style study, and it should also be benefited some way in machine learning. For example, whether we can know from how the faces are painted and what colors are used. In a way, we can discover not only how a story changes their form through history, but also how a story is being depicted. And the reason we want to propose this dataset is to bridge this gap. And to build upon the facial expression collection, we propose to make a machine-friendly dataset. And name-wise, we call it Kaokole, which is short for the facial expression collection in Japanese. And now we want to show the value of our dataset through two types of experiments. The first type is called the quantitative classification result, which basically just show the supervised learning task being asked to classifying the gender and the social status. So here, in detail, the machine learning models are required to classify whether a given image is a male or female character and the character social status. So we show the result of several commonly used neural networks, which are able to achieve like decent but imperfect performances. So definitely the newer and larger architectures achieve better performances, but they still do not um, get it perfectly right. So actually what we first try explore is the generative adversarial network or GANs, which has been successful in synthesizing the high quality images. So in this task, we leverage the style GAN, which was one of the state-of-the-art GANs at the time of writing, but arguably now with developing and with more and more better like these high fidelity image generation models being proposed, there are definitely already better models. We also explore another work which is called Learning to Paint by Huang et al. This one is a unique neural painting model trying to approximate the images using very simple regions marked by the quadratic Bezier curves. And this model aims to use such kind of regions as few as possible. So we show here that this model generates the sequences of painting vividly, but much different than the previous cited model. So this shows that the produced curve region actually learns a way to approximate the painting in a pretty abstract way. And this emphasizes the general arrangement of the objects rather than the details. So we believe that these two explored painting model can give us some samples of the fundamentally different learning mechanism can be leading to like a different generated image, the generated image with different styles. We attempt to like study like the changes of style through as the time changes, either through a humanities point of view or using the computational approaches. But our very primitive finding is that a painter's style is more correlated. It's hard to say the causality, but speaking of the correlation, it's pretty related to the time the painter was on. The interdisciplinary research of humanity and machine learning is something that's a pretty unique. It itself needs some kind of creativity.